The chemistry we've done so far this year has been very qualitative. Now it's time to look at the quantitative side of chemistry. It is a very quantitative science in that eventually when we do reactions, we're concerned with quantities. How much of this reactant do I need? How much product is formed? How much energy is released? What volume of gas is produced? That we're concerned with quantities and amounts of particles and reactants and products. So it does become quantitative, which means that we're concerned with specific quantities. And so give this a chance here. This first section is getting us eventually at something called a mole concept, which is a way of measuring amounts of atoms and molecules. But before we get to atoms and molecules, we're going to think about it in terms of things that are a little more concrete, like apples. We can count apples easily, but eventually we run into a little bit of a snafu in that we can't directly count atoms and molecules because they're crazy tiny. So I can't just have a sample of copper and then be like, oh yeah, let me just count the copper atoms. How many copper atoms produce? Oh, let me sit and count. And so we have to kind of get at that through other methods. And that's what we're setting up here in this first part of the unit, in that we can quantify apples by their count, in that 12 apples are a dozen. I can count 12 apples. Now, could I have 12 copper atoms? Of course. But I just personally won't be able to count them. We can quantify by mass. So 12 apples is a dozen. A dozen is 2 kilograms. Or we can maybe quantify by volume. A dozen apples is 12. A dozen apples weighs 2 kilograms. Or maybe a dozen apples would be 0.2 bushels. And all of these are relationships then that we can use to convert between different units. Do I want to measure by count? Do I want to measure by mass or volume? And eventually we can do something like this, which is referred to as dimensional analysis. And maybe you've done this in like a math class where you were given a certain distance. Maybe it was in centimeters, and you wanted to switch centimeters to inches, inches to feet, feet to yards, yards to miles, something like that, where you're using these conversion factors or these relationships to set up proportions and eventually convert between one unit and another. The rule of dimensional analysis is that the unit that you want goes on top of the proportion. The unit that you want to cancel will go on the bottom of the proportion. So for example, here they wanted to know the mass of one apple. And so they said, okay, well, let's say I start with 1 apple. And then they canceled 1 apple. I don't want my final answer in apples, so I'll put that on the bottom. We canceled apples, and then on the top they switched it to a dozen. So if I plug that in my calculator, it would be like 1 divided by 12. 1/12 of a dozen is 1 apple. Duh. Okay, so now I would be sitting at dozen apples, and I can use another conversion factor. I don't want my final answer to be dozen apples, so let's cancel that by putting it on the bottom of my next proportion. And then the unit that I want goes on top. Kilograms is a unit of mass, so I want kilograms on top. Now if I plug all this in my calculator, you'd multiply any of the numbers across the top and divide by anything on the bottom. So you'd start with your 1 apple, and you could say like 1 times 1 divided by 12 times 2 kilograms divided by 1, although obviously you don't have to plug in the multiply by 1 or divide by 1. So in a nutshell, I could say 1 times 2 divided by 12, or 1 divided by 12 times 2. And that should give me a mass of 0.17 kilograms per apple. That should be the mass of an apple. So the unit that you want goes on top. The unit that you want to cancel will always go on the bottom. And then I think it's helpful to cross them off. It just gives me pleasure, I guess, to cross off a unit if I know that I've got it on the top and the bottom and it cancels. So that in the end, the only unit left should be the unit that I want. So if I wanted this in mass of an apple, kilograms is my unit of mass. So we could set this up with dimensional analysis. We could use a graph. We could set up a graph like this. Here is total mass as a function of number of grapefruits. What is the slope of the best fit line? What does this value mean? Okay, well, slope is rise over run, right? So I don't know, let's just pick some numbers that fall on the line. Like maybe 2. Let's say I go to this point. I want the slope. Rise over run. 0.5 kilograms divided by 2 grapefruit. Now, when we're in science doing calculations, the numbers mean something. Science is sometimes better than math. I mean, in math, you would just take 0.5 divided by 2, all done, and plug it in my calculator, I'm all done. But now the numbers mean something, so we want to put units behind all of our numbers in science. This is 0.5 kilograms per 2 grapefruit. All right, so I plug that in my calculator, and I'd be looking at about 0.25 kilograms per grapefruit. Okay, and now if you remember anything about slope, I mean, let's say we do that at another point, like another easy point. Say, let's pick 4. Okay, rise 1.0 kilograms over run 4 grapefruit. Oh, well, what do you know? It's the same. 0.25 kilograms per grapefruit. It's constant, right? I think because I can look at my graph and I do see that it's a constant slope. It's a nice straight line. Okay, so there's my slope, 0.25. What does this mean? Well, that's where we can look at the units. Kilograms per grapefruit. That's the mass of 1 grapefruit, right? And it should be constant. I mean, obviously grapefruits can really come in like different sizes, but here we're saying that all the grapefruit are approximately 0.25 kilograms each. That's what the value means. It gives me the mass of 1 grapefruit. Predict the mass of 8 grapefruit. Well, if I use this data, would I maybe predict that if every 1 grapefruit is 0.25 kilograms per grapefruit, and I have 8, could I just multiply? And then what would we say? 0.25 times 8 would be like about 4? Oh, wait a second, 0.25, that's 2, hello. 2 kilograms. Look at that. 0.25 times 8. 2 kilograms should be the mass of 8 grapefruit. Could I kind of confirm that? I guess. I mean, if we look at the graph and maybe we were to take this line and extrapolate it and kind of extend this. Yeah, that's probably pretty close, huh? And 8 grapefruit should be right around 2 kilograms. And so again, it's just that we want to kind of look at quantities versus mass. And often we're going to want kind of a ratio in that, you know, maybe I can't measure 1 atom. I think 1 atom might be really, really, really tiny. There's no way I can count one atom, and there's no way I can mass one teeny tiny atom. But maybe if I had a large quantity of atoms, I could find the mass. And if I knew the mass of a large quantity, then maybe I could use some ratios and dimensional analysis to find the mass of one teeny tiny atom.